Hi everybody, it's Miss Lee here. Today we're going to be talking about graphing quadratics from standard form. Standard form is when you're in the form of y equals ax squared plus bx plus c. So this is the example question we're going to be doing. So if you want to pause the video here so you can write this down in your notes, that would be great. And that way you'll be able to follow along as we go. Okay, so the question says, given the function y equals negative x squared plus 8x minus 7, list out the traits, including the vertex, the axis of symmetry, the maximum or minimum value, whichever one that may be, the y-intercept, the symmetrical point to the y-intercept, intervals of increasing and decreasing. And then I want you to also sketch the graph. Okay, so we're going to go ahead and do this together. So let's start with the vertex here. So we're going to find the vertex and the axis of symmetry sort of at the same time, because obviously once you've found the x value of the vertex, you've found the axis of symmetry. As you guys know, the formula for the axis of symmetry is x equals negative b over 2a. That's the formula for the axis of symmetry, which therefore is also going to give you the x value of the vertex. So we'll go ahead and plug in. As we said, this is in the form of ax squared plus bx plus c. And so a is going to be -1, and then b is going to be 8. So -8 divided by 2 times -1. Okay, so just to reiterate here, this is the b. This is the a. Of course, that minus sign is the a, meaning that there's an invisible 1 there, so it's -1, or an implied 1. Okay, so if we simplify this, that would be -8 over -2, which, as you know, -8 divided by -2 is 4, which means x equals 4 is the axis of symmetry. This is the axis of symmetry, so we'll keep that in mind for later when we're graphing. For the vertex, we'll go ahead and plug in the x equals -4 and find the y value. So right now what we're doing is finding the y value of the vertex. And so we plug in 4 and we have negative and then 4 squared and then plus 8 times 4 minus 7. So a lot of you guys are really good at making this one mistake where you say, oh, -4 squared, that's 16. But that minus sign is kind of like on the outside. So if you think about like multiplication, that comes after exponents. And so what you want to do is always square that number first, square the x, whatever the x is, because the square, as you can see from the original problem, the square is on the x. It is not including that minus sign that's in front. And so we're going to go ahead and square that 4. And so if you square that 4, we get 16. And so you can think of this as like only the 4 is in parentheses. And so then we have -16 plus, and then 8 times 4 is 32 minus 7. So we have 16 minus 7, which equals 9, which means the vertex is 4, 9. Those are the coordinates of the vertex. Okay. And so, as you guys know, the a value is going to tell you, this a value is going to tell you whether it's open up or open down. So because this is negative, this parabola is going to be open down. If you have an open down parabola, is it going to be a maximum value or a minimum value? Well, we've talked about this before. If the vertex is at the top of the parabola, that's a maximum. And so then to find the maximum or minimum, you determine whether it's a maximum value, and we use the y values of the vertex. So 9 is the maximum value. Okay, and the next thing it says to find is the y-intercept. When we're in standard form, this is extremely easy. because you're just finding f of 0, because for y-intercept, all you have to do is plug x equals 0 into your function. But really, if you plug f of 0 into your function, you're going to get negative 0 squared plus 8 times 0 minus 7. And those two terms right here, the 0 squared and the 8 times 0, that's going to go to 0. And it's always going to go to 0. And so then minus 7, it's going to be minus 7. In general, the y-intercept when you're in standard form is always going to be the c value. Okay, so when we're in standard form, only in standard form, that last number at the end is going to be your y-intercept. So we have a y-intercept of 0, negative 7. That's going to be the y-intercept. Okay, I'm going to go ahead and start graphing some of these so that we can kind of have a visual of it. What I want us to do is start with the vertex and axis of symmetry. So the vertex was 4, 9, so right here. So vertex was 4, 9. Okay, that's really dark. Okay, the vertex is 4, 9, and then we're going to do the axis of symmetry at x equals 4. And then we had I'm going to draw in that point a little bit more clearly there. Okay, 4, 9. And then we had the y-intercept at 0, negative 7. And as you've seen before, to find your symmetrical point to that, since it's 1, 2, 3, 4 units away from the axis of symmetry, we're going to go ahead and draw a point 4 units away on the other side. 1, 2, 3, 4. And so that's going to be our symmetrical point. And so if we're looking at that, that's going to be 8, negative 7. Okay, so it's easier to kind of just look at the graph to find your symmetrical point. So I'm going to go ahead and write that in our notes after. Actually, let's draw the graph first, and then I'll write that in our notes. Again, when you're drawing these parabolas, your drawing needs to be smooth, and make sure your ends of your parabola don't start to go unreasonably outwards. So that's the drawing of our parabola. So we've already sketched it. However, something we have not addressed yet is the intervals of increasing and decreasing. So the meaning of intervals of increasing and decreasing is the graph increasing as you go from left to right, or is it decreasing? So in general, when we're talking about increasing and decreasing, you always want to look at it as going from left to right. So if you're looking at this going from left to right, you'll see that over here, the graph is going upwards, up, until you reach that axis of symmetry, and then the graph starts decreasing. So it kind of has a negative sloping sort of look there. That's decreasing. Increasing or a positive sloping type of ordeal. So we're going to say, so since this has an arrow at the end of it, that means that it's going on towards negative infinity. So we're going to say that from negative infinity all the way up until x equals 4, this graph is increasing. Okay, so let's go ahead and write that out. I forgot to write the symmetrical point. So symmetrical point, we said, or we agreed that would be 4, nope, it would be 8, negative 7, I believe. So it's going to have the same y value as the y-intercept, or the point that you're, reflecting across. And it's going to be the same distance away from the axis of symmetry. So since the axis of symmetry was at x equals 4, and the y-intercept was 4 units away, then this is going to be at 8, x equals 8. So this also makes sense. Okay, let's talk about the increasing intervals. So increasing / decreasing intervals is what we're going to put over here. So we're going to say increasing on the interval from negative infinity, and then that's going to go all the way up until 4. And then the graph is going to be decreasing for the rest of the way. So that'll be from 4 up until positive infinity. So from 4 until positive infinity. Okay, and so we've graphed it and we found all of the traits. Yay!